Hello Evie, how are you? So we're doing the exponential graphs, by the way, like you requested last time. Hello Ma, how are you? I'm doing pretty well, not too bad. Can't complain. So the paper 1, like the first paper 1 is there, but the paper 2 and 3 are taking slightly longer than I thought. But yeah, the B and C, so like, remember how I said like paper 1 has 3 variants, A, B and C. A is up there right now. B and C are taking slightly longer. But actually let me just double check that. But once they're done, yeah, they'll be all as like a bundle, which might be a bit better. Fair enough. Okay, so yeah, we'll just get started with the exponential stuff. So with the exponential graphs, it's a somewhat small topic in your exam, but it is one that's quite important. So what does the exponential graph look like? Well, it's just going to be y is equal to a to the power of x. So this here is called your base, and it always stays the same. And x is obviously the one that actually varies. Okay, so as an example, you might have something like y is equal to 2 to the power of x. You could have y is equal to 5 to the power of x, and so on. Okay, so what would these look like? Well, you may be asked to plot these, so in an actual plotting table, which, in my opinion, isn't the tricky part of these questions. Again, we'll go on to like the actual proper exam questions in 1 second. But what they could ask you to do is do like a little plotting table for them. So they might have like, you know, x and y, then -3, -2, -1, 0, 1, 2, and 3, right? Very messy, but then you just fill in the plotting table. Are all of you okay with doing that? So again, you're just replacing x with these numbers. So if this was for the y equals 2 to the power of x, 2 to the power of 0 would just be 1, 2 to the power of 1 would be 2, 2 to the power of 2 is 4, 8, and so on, okay? Perfect. So I'm just going to go through what the generic shape is. So if we have just a regular graph, it's going to look like this. All of them will look the same. And it shoots off. So what are the interesting parts? And again, this is for any exponential graph, so even when it comes back in A level, which is where it becomes a bit more interesting, it's going to look exactly the same. So again, we can have our little x-axes and y-axes. Now this coordinate here is always 0, 1. 100% of the time. Again, if it's in the form a to the x. So there can't be any plus, right? There can't be +2 or +3 or -1, -2 or anything like that. If it's just y equals a to the x, it always passes through 0, 1. Have a think. Why is this? Well, anything to the power of 0 will give me 1. That's why. The other interesting thing is this bottom line here is something called an asymptote, which you may or may not have heard of, and that's at the y equals 0 line. So what is an asymptote? An asymptote is a line on a graph that the curve will never ever touch or cross. Okay? Which again, have a think about why that might be. Why could it never cross this line? Well, if you think about it, here we're getting more and more negative, right? And when you have a negative power, all it does is it makes it 1 over the number, right? So for example, again, let's imagine this is y equals 2x. When x is -1, you would have y is equal to 2 to the -1, which is just equal to 1 over 2. If it was x equals 2, you would have y is equal to 2 to the -2, which is 1 over 2 squared. And so on and so forth. So, this bottom number will get bigger and bigger and bigger, but there is no number you can divide 1 by that will give you 0. So you can never cross this line, and it's called an asymptote. This does come back in A level, again, talking a bit in the future, but asymptotes are quite important. So just as a reminder, they are lines that the curve will never ever cross. Okay? And not many graphs have them, but you've also seen them on the tan graph, actually. Right? You know those dotted lines that come up every 180 degrees? So that's another thing. So far, is that all okay? Is it all stuff you already know? Yeah, perfect. Okay, so we spent about 3 minutes on that. Let's get to the actual question. So, fairly standard exam question. Sketch the curve with y equals 2 to the x. So, all you need to do, and here's what they're marking you on, by the way. I'll tell you exactly what they mark you on. So here's the marks that you can get. The first one is obviously the shape. The second one is for labeling the y-intercept, right? Now, what are they looking for shape? The key thing is that this cannot touch the x-axis, and it can't look like it's going to. So make sure you level it off. So for example, if I were drawing this and I made my graph touch the x-axis at all, you lose a mark. You lose the mark for the shape. For the y-intercept, you can always put it in. It's always going to be 0, 1. So just remember to put it in. But that's the two major marks you can get here. A third mark, again, depending on how many marks the questions are, would be given for the asymptote. So implying or saying what it is. So you could just say something like asymptote at y equals 0. Okay? But again, the key thing to remember is it can't look like your graph is touching it. Okay? So I would always stop above the x-axis. So where I stopped is pretty good because there's no ambiguity there. It's definitely not touching the x-axis. Okay. Again, fairly standard question. Here's where things get a little more interesting. Again, these questions don't come up that often, but they could come up. So we have a graph with the equation y equals pq to the power of x. P and q are just constants, so they're just numbers. The points with coordinates 0, 8, 118 and 1.5k lie on the graph. Calculate the values of p, q and k. So again, you might notice that the y-intercept is not 0, 1. That's because of the number p that's in front. Okay? So what we're going to do? Well, I've kind of given you the answer already, but let's go through it. What we can do is sub in values using our coordinates. So when x is equal to 0, y is equal to 8. So if you have a look at that, we have, again, just subbing into this equation here, we have 8 equals p q to the power of 0. Now this whole thing here, q to the power of 0 is just equal to 1. So in other words, we have 8 is equal to p. Nice and easy, right? And again, you could just look at the graph and see this y-intercept value is always the number in front of your base. Okay, it's always going to be where p is. Working out the other value is then just a matter of substituting in anything. So I'm going to substitute in the 1 and 18. So when x is equal to 1, y is equal to 18. So again, we have 18 equals p, which is now 8, q to the power of 1, so just q. Which means q is just going to equal 18 over 8, which is just 9 over 4. I'll leave it like that because there's not much point in simplifying any further. So far, are we all okay? Hopefully. And the last point to find out okay? Yes. So P, again, so I showed you two ways to work out what P is. One way is if you look at the graph, right, and again, have a think about it, right? When x is 0, this anything to the power of 0 is 1. So you just have the y value is equal to P. So yeah, because it's the constant, P is equal to 8, Q is equal to that. And then finding out what K is, well, what they're basically asking me is x is equal to 1.5. What does y equal? Well, y would equal 8 times Q, which is 9 over 4. I'm going to put it in brackets, to the power of 1.5. This is definitely a calculator question. Actually, you don't need a calculator. So this could show up on a non-calculator paper. Would you guys be okay with doing this without a calculator? So, just to be clear, this is usually on a calculator paper, but it could be somewhat interesting to know if you... Okay, you know how to do that without a calculator. Okay. Alright, let's just use a calculator then. But without a calculator you're fine, that's good. So, 8 you want me to go through it? That's... Wait, how? Yeah, okay. Okay, let's do it without a calculator. Let's make it a bit fun. A little bit fun. So the way I would do that is I'd say 1.5, right, so ignore these brackets, is 3 over 2. Right? Yeah, hardcore. So now we have y is equal to 8 times 9 over 4 to the power of 3 over 2. Now when you have square root and cube, but yeah, I see what you mean. Yeah, I got you, yeah. So when you have like powers like this, you need to cube the values and you need to square root them. And the order is up to you, right? But if we be a little bit intelligent about it, you always want to square root or cube root first because it makes the numbers smaller and then you can cube up. So for example, if I cubed 9, right, and then tried to square root it, it's very tricky to know what that is, right? It's a lot harder than square rooting 9. So I'm going to square root both. Wait, I'm assuming that's okay. So just so you're aware, 9 over 4 to the power of 3 over 2 is the same as just saying the square root of 9 over 4 all cubed. Okay, so you take the top power, that becomes whatever this is, and this is whatever root you're taking. It could be the square root, it could be the cube root, or the fourth root as well. No problem. So 8 times, so square root of 9 is 3, square root of 4 is 2, cubed. So then keep going. 8 times 3 cubed is 27, 2 cubed is 8. So 8 cancels with that 8, so it's just 27. That was nice. Not too bad. Again, if you entered it in a calculator, that's totally fine. I've only ever seen these questions on calculator papers, but this one specifically, since it's not too bad to do without a calculator, I suspect it may have been a non-calculator question. Not too bad, I think. With exponentials, by the way, there's not much in your GCSE paper, but I figured we may as well do some of these. I did steal these from Corbett Maths, this one here, just so you're aware, so the ones with the red and blue lines, because I ran out of exam questions. But these are pretty good. Very similar to what we just did. So the sketch shows the curve with the equation y equals ab to the power of x, where a and b are constants and b is greater than 0. The curve passes through the points 0, 3 and 2, 12. Calculate the values of a and b. Again, immediately I can say a is going to be 3, right? But if you're ever unsure, just sub in the values. So x is equal to 0, you have y is equal to 3, so that means 3 is equal to a b to the power of 0, b to the power of 0 is 1, so 3 is equal to a. So yes, it is always going to be the number in front, but again, if you're unsure, substitute in, okay? There's no sense in risking stuff. Next thing we have is 212. So let's sub that in. So we have x is equal to 2, y is equal to 12. And again, we're going to have 12 is equal to, we know what a is, so I'm just going to sub in a, and then we have b to the power of 2. So now what would you do? Well, this is something I see some students do, is they try and square root first. That's not wrong. You can square root first. It's just not the easiest thing to do. I would always get rid of the number in front of the variable first. So divide both sides by 3, and you get 4 is equal to b squared. Square root it means you get b is equal to 2. Not too bad. Now, actually, let's go a little bit advanced. Just a tiny bit advanced. Technically, when you square root a number, you get plus or minus 2, right? So why did I just write 2? Give me a second just to ruminate on that. If this was minus 2, right, the graph would look extremely weird, right? So let me write out. Let's say hypothetically it was minus 2, right? So we have 3 times minus 2 about x. Y can't be negative, that's good. I mean, y can be, right? It can be, as long as it doesn't cross the x-axis. So with this graph, if you were to flip it, it still wouldn't touch the x-axis. But if you look, when x is 1, for instance, right, then y is going to be negative. When x is 2, y is positive. So what you're going to do is you're going to get the graph alternating from below the x-axis to above, to below to above, below, above, below, above. And they wouldn't join together in between. Yeah, which is very weird. That's why I chose a positive. It would just bounce up and down constantly. And the thing is, they wouldn't even be connected, the parts of the graph. So it looked kind of like the tan graph, you know, where you have those bits that are disconnected from each other. But it won't look exactly like the tan graph, but it have that kind of characteristic. So that's how I know to always take it to be positive. Okay? You don't need to know that, to be honest, but I thought it might be somewhat interesting for you to think about. Again, with exponentials, there really wasn't much. So if you find this easy, you can either ask me whatever questions you have, or we can finish off that predicted paper. Yeah, trivia, basically. With sketching, sorry, plotting even, are you guys okay? Or would you like me to do this question? 1/3 to the power of x. It could be calculator or non-calculator, to be honest. Because the biggest number you have to deal with is 3 to the power of 4. Okay, I can do this question. Alright, so go through it. Okay, yeah, okay, cool. So, do you have the ones where you need to solve, I can't read. Need to solve an equation with both of the points on a denominator. So, like it would be like this, like PQ. Or something like that. If you can find one, that would be perfect. I don't think I have those, although I did make this lesson last week, right after you said, and it's been a long week. But yeah, okay, I'll do this question anyway. Okay, thank you, Evie. In the meantime, I'll do this question. So what you'd want to do is set up your little plotting table. And please forgive my... One. Okay, this is going to be quite long. Alright, 2. We'll do our working out outside, but the first one I can always fill in is 1. Right? That's the first one I can fill in. Why? Because anything to the power of 0 is 1. Okay? So, let's think. What would be the easiest one to go through? I think it would be easiest to start with x is minus 4. So when x equals minus 4, can you guys still see that? I'm going to zoom in slightly. Make it a bit nicer. When x equals minus 4, we have y is equal to 1/3 to the minus 4. So if we try and think of our rules of indices, when you have a negative, you flip the inside. So this is the same as saying y is equal to 3 to the power of 4. Technically 3 over 1 to the power of 4, but you don't need to write them over 1, so I just didn't bother writing it. Now 3 to the power of 4, well 3 cubed is 27, so 27 times 3 is 54, 81. 81. Now, I'm going to do this the long way, but there's a shortcut. Okay? If you spot the shortcut, really well done. But if not, you can see this. Now, can you see that with minus 3, I'm going to have a very similar situation, right? I'm going to have a third, minus 3. I'm basically flipping it to make it just 3 over 1, so 3 cubed. So that's 27. Right? And this one will be 9, and this one will be 3. Is that okay? Now the trick I'm going to show you by... I'm going to start with x equals 4, right? You see the shortcut? Okay, good. So again, if I do this, then I have 1/3 to the power of 4. If you're unsure of how to do fractions to the power of something, all you're basically doing is doing 1 to the power of 4 over 3 to the power of 4. Okay? So I'm going to ignore the 1 because 1 to the power of 4 is just 1 over 81. Okay, so 1 over 81. Interesting. It looks like this, right? Okay, let's do one more. What about x equals 3? Well, again, 1 cubed is also 1, because it's just 1 times 1 times 1. And that's over 27. Interesting. It looks like that. So, all they are 1 over their corresponding 1. So minus 4 is 81. 4 is 1 over 81. So you can now just fill it in as 1 over 9 and 1 over 3. So once you get a bit faster, you'll be able to do this really, really quickly, and you won't have to work them out individually. Okay? I would say you would have to do 1 fully, but then you'll see the pattern and you'll just go, okay, so 81, so that'd be 27, 9, 3, 1, and that'd be 1 over 3, 1 over 9, 1 over 27, 1 over 81. So it becomes a lot quicker after that. But is anyone unsure at all? If not, I'm going to start writing this out anyway. So how many squares do we have? So we need to go from minus 4 to 0. So there's 1, 2, 3, 4, 5, 6, 7. Of course there is. So we need to go... We could do minus 4, minus 3, minus 2. No, we can't. Okay, great. Looks like we're going to have to go up in technically 1.5s, but I'm not going to do that because that is extremely tedious. So minus 1, minus 2. The graph is ever so slightly too short, and now it's going to look really ugly. So just as a recommendation, I'd recommend using the whole of the x-axis that they give you. Now, you might be thinking, well, sir, you're not doing that at the moment. That's because whoever made these axes didn't make it long enough. There should be one more square. But in your exam, the examiners make it so it's long enough for you to fit it in perfectly. I need one more square on either side in order to do this. Should I just add the extra square? It's going to look weird. Okay, now I'm not going to do it. Okay. Then we just need to plot it. So what are we going up? We need to go from 0 all the way to 81. This is going to be incredibly difficult because we have fractions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That doesn't really go into 81. 15... It doesn't go into 81, but it's really close. Actually, no, it does. I'm just going to go up in tens, but every 2 things. So that'd be 10, 20, 30, 40, 50, 60, 70. Okay, that fits. It doesn't fit perfectly. Okay. That's fine. So just so you're aware, the very, biggest number is not going to fit. But again, these axes are not really perfect. So 81 is going to be slightly off. I apologise. So minus 4 goes up to 81. So I'm going to put it just above here. Minus 3 is 27, so it'd be slightly closer to 30, so here. Minus 2 is 9, over here. Can you see how quickly it's dropping, by the way? Minus 1 is 3, right here. 0 is 1, which would be like down there. And then it's just going to get closer and closer to that. Okay. So actually drawing these graphs can be a bit tricky, but again, you want it to drop down and then it needs to level off. Okay. But again, look how big the gaps are and how they get smaller each time. Kind of interesting. And then again, you need a smooth curve. I'm just gonna start that again. Okay, I'm sure you guys know by now that I can't draw very well on the computer like this. But you want a smooth curve that goes through the points. Again, I can do it on paper really well. Doing it on a tablet is a bit hard. What is level 2 further maths? I believe that's GCSE further maths, if I'm not mistaken. It's like a GCSE that's between A-level maths and GCSE maths. So with plotting, is that all okay? So Alia, is that okay? Maybe. It's definitely possible. I was actually tempted to get some A-level maths questions for this lesson, but I didn't. Yeah, that's fine. Cool. So this is something that can come up. Again, I've only taken the part of the question that was actually relevant, So the price, P pounds of a car, is £20,000 in 2019, and it's expected to decrease by 5% each year. So circle the graph that best represents this. So something that's quite, again, I want to say interesting, but I know you guys probably don't find it interesting, is that compound interest and depreciation are both exponential graphs. So compound interest and depreciation are both exponential graphs. Yeah? You might already know that, but again, hopefully that makes sense. If you think about the equation, you have something to the power of the number of years. So that is literally an exponential graph, or again, the kind of inverse of that. So which one of these looks exponential? Well, I can definitely eliminate this one, right? That's linear. It's not going to be exponential. So it's definitely between this one and this one. And it's pretty close. But what you need to remember is, will it start off steep, or will it end up steep? Will it increase over time? Okay. Now, exponential graphs, no matter what they look like, will always be steepest at their beginning. Okay? So, I mean, in the graph we just drew, look, it's steep here and then it levels off. And then when we did the exponential increase, it's steep, but I mean, this one's a bit of a worse example. But again, this is the actual decrease we're doing, right? So it starts off really steep. So it's actually going to be this one here. Which is actually why they give you 2 marks for this one. Does that make sense? Any questions about that at all? Sorry, I circled the wrong one. My bad. My bad. I said what I meant, but yeah, it should start off steep and then level off. Whereas if it's increasing, it starts off slow and then speeds up. Yeah, that's my bad. Yeah. Okay, cool. Well, that's really good. This one's definitely a calculator. So the number of gannets on an island is assumed to follow this exponential growth model. Again, this is a GCSE question, but it comes up again in A-level maths because you do a lot of stuff with exponentials. So n is the number of gannets in the last question on your paper. Absolutely, I can. Yeah. Well, we're definitely gonna have time. I don't have much more because there really wasn't much to do with this. But n is the number of gannets in thousands. X is the number of years after the 1st of January 2010. So this is basically a compound interest question, right? If you think about it, exponential growth. So we need to do is sub it in. This is definitely a calculator question. So when x equals 10, so we have 0.45 multiplied by 1.07 to the power of 10. I said to the power, there we go, to the power of 10. That gives me 0.885. So if I look at the other values here, it's to 2 decimal places, so I'm going to give it to 2 decimal places. I think that makes sense. How bad is it if I've lost my mock papers? It's not the worst, but they are quite useful in terms of revision and kind of testing what's better. So something that I've got some of my students to do, is they had a mock, it's been marked and given back to them. I've asked them to keep it because in a month, they're going to redo the mock paper and see how much their grades improved by. Again, it can be kind of useful. Again, I'm just changing the 20. But if anything's not very visible, let me know and I can go back through it. 1.74. And again, it's just plotting. Not too bad. So 0 should be 0.45. So we have 1, 2, 3, 4, 5 blocks. So it should go up in 0.2s. So not 2s, sorry. 0.1s. 0.1, 2, 3, 4. Yeah. So 0.45 would be right here. Okay. 5 and 0.63. So this is 5. That's 6. So 3 would be maybe here. 10 is 0.89. So that would be 5, 6, 7, 8. Right underneath 0.9. 15 is 1.24. So we have 1.1, 1.2. 0.4. 24, sorry. and 20 and 1.74, so 1.6, 1.7, and then halfway between the next one. And it says draw the graph, so again we're just going to do a nice... okay. Not the worst, but not bad. In fact, did I plot that point correctly? Wait, 1.2. Yeah. I mean, I could make it slightly lower, I suppose. Right? Oh, that was terrible. Okay, I'm sure you guys get the point. But yeah. In terms of... And this is the last one that I found for this paper, actually, for this topic. A 3 marker. This is actually on the OCR exam board, but again, I like to repeat this every now and then. All of the exam boards have to follow the same spec for GCSE. They don't for A level, and there's a lot of difference, but for GCSE they have to follow the same spec. So, the point 3 and 1/64 lies on the curve y equals k to the x. Show that the point half-half lies on the curve. The only way to do this is by finding out what k is. Okay? So, and the reason for that is normally to show a point lies on a curve, you sub in these two values, right? So you'd sub in x as a half, y as a half, and then show that they're equal. The problem with that is we don't know what k is, so I can't square root k. So, x equals 3, y equals 1/64. So, again, you might be able to spot already what the answer is. K cubed. So what you want to do is cube root both sides. I can go through that question. You're funny. Can you send... If you have a link to it, that would work as well. So like find it in a past paper and then link me it, that'd be fine. And what is the cube root of 64? So yeah, if you send me like a link or something, I can do that for you. Cube root of 64 anyway is 4. So it'd be 1/4. So now our equation becomes 4 of x. So show that the point lies on the curve. Well, x is equal to a half. Let's see what y equals. Well, y is equal to a quarter to the power of a half, which is the same as square root of a quarter, which is definitely 1/2. So it is. That's the last exponential question. So you're funny, if you want to like send me the link of a question or something like that, that'd be fine. But for now we'll go through, so just for those of you that weren't here, I have a predicted paper. Okay? Technically I have a lot more than that, but okay, let's quickly do this question, that thing we sent. It's a shadow set. The curve passes through the point P with coordinates 1.51 and the point R 432. Hang on. Oh, it's very similar to this one. Okay. So I'm just going to copy and paste the question in. We'll do this one, then we'll do that quickly. Alright. So we have a point passing through the point P with 1.51, R with 432. So if you'd like, you could even sketch this out if you wanted to. Ah, I see why this is harder. Okay, fair enough. I'll sketch it out. So we have coordinates minus 1k, which I'm going to put over here, 1.51, and 432. Okay. And we basically need to find the value of k. But to do that, first of all, is everything big enough? Can everyone see everything? But to find the value of k, what we need to do is find the actual like expression for this graph, right? So, in general, this is what they look like, right? So a, b to x. They have some number times a number that's to the power of x. And Yeah, I don't know anything else about the curve. So, this is a really good question because it also involves simultaneous equations. So, what we're going to do is use the information that was given and substitute it in. So, x is... oh, God. Don't know what I was trying to write there, but x is equal to 1.5, y is equal to 1. So, we have 1 equals ab to the 1.5. And in the next question, in fact, this... okay, no, it should be fine. This is a GCSE question, right? You know what? Even if it isn't, this will be a fun challenge. 32. We have 32 equals ab to the power of 4. Okay, well, this is fine. This is actually fine. This would be completely fine. So, again... oh! Oh, okay, perfect. Well... thank you very much, You're Funny. I appreciate that. So, hopefully, I'd just like to point this out. If you did this step, you get marks. Probably just 1. But all I've done is I've written the information from the question. The hard bit is the fact of this. So, I just want to be sure, is everyone 100% clear on how I got this? Like, where I got this from? The sketch isn't necessary, but I like to draw things out, even though I suck at drawing. Just to make myself see. But is everyone okay, yeah? Everyone's okay. Cool. Now, this is a simultaneous equation, but it's a bit of a cheeky one. Okay? Because I don't think... no, you would have never solved a simultaneous equation like this. Right? There are 2 ways. One way is painful. The other way is not too bad. Can I ask, was this non-calculator or calculator? Do you guys remember? I can do it with either. So if you don't remember, we'll just do it without a calculator. Actually, yeah, I can do it with either. Non-calculator. Okay, that makes it fun. So, one way is like the normal way, right? You would rearrange, you'd have to use substitution. You'd have to rearrange for A, get some stuff, and then sub it into the other equation, right? Painful way with non-calculator. So you want to do the painful way, okay. You know what? Let's do it. Let's do it the painful way. Okay. So this is the painful way, using substitution, right? You would rearrange for A, and you'd sub it into the second equation. Yeah? So, should we start with that? So if I rearrange A, I'm going to divide both sides by b to the power of 1.5, so I get 1 over b to the power of 1.5, which, I don't know if you would have seen this, I can write that as b to the power of minus 1.5, right? Because again, I can just bring the power to the top and make it negative. Yeah? And now I'm going to substitute. Now you have to substitute it into the other equation. You have to. Okay? So now my equation 2 looks like this. And I'll show you a shortcut afterwards. Okay? Or at least what I find to be a shortcut. So we have 32 equals b to the power of minus 1.5 times b to the power of 4. Now what happens when I times 2 bases? I add the powers. So that is b, so 4 minus 1.5 is 2.5. Ooh, okay, this is actually a bit... actually no, this is fine. I don't know why I'm making faces like that. Kind of. The shortcut is to take equation 2 and divide it by equation 1. And it cancels out a, and you would get to this step straight away. That's the shortcut. If you divide the 2 equations. Ah, okay. Now, if this is a non-calculator, I would have to write this as b to the power of 5 over 2. I know everyone hates fractions. I hate fractions too, but that's what we got to do. Okay? Now, so where things get fun. I need to basically make this b equals, right? So, and I want you to be... I'm going to try and say this in one way to see if you guys get it. To get rid of the over 2, I'm going to square both sides. Right? So 32 squared equals b to the 5. I'm not going to work out 32 squared. That's too much. And then I'm going to take the 5th root of both sides. So take a second to digest that. Because that's a bit tricky, I'm not going to lie to you. But essentially all I'm doing is I'm just flipping this fraction and putting it over here. And the way I'm doing is I'm squaring both sides and taking the fifth root. Kind of. Can you not square it with this? No. Because again, I'm not actually doing this bit, right? What I'm doing is I'm squaring this number and taking the fifth root of that number. You have to rearrange it. So it's actually the exact opposite. You're taking the fifth root and squaring. So again, I'll leave that for a second just to make sure you guys are completely okay. Now, as you guys have pointed out, what I'm going to do is take the fifth root of this, of 32, and then square it to give me b, which fifth root of 32, yeah, well done Evie, fifth root of 32 is 2, so 2 squared is 4. This must have been like a 5 marker, right? 5, 6 mark, at least? Because it's a simultaneous equation past this. Okay. So I know that b is equal to 4. 4 marks? Jesus Christ. Alright. Maybe. I mean, the simultaneous equation should be 4 marks. Ah, forget it. Alright. Now, if b is equal to 4, we can substitute that into any equation we want. I personally think if we just substitute b is equal to 4 into a is equal to 1 over b to the 1.5. I wrote b. One sec. Alright. 4 to the power of 1.5. So if we work out what 4 to the 1.5 is, that's the same as doing 4 to the 3 over 2. So all you're doing is you're square rooting 4 and then cubing it. So square root of 4 is 2, cubed is 8. So it's 1 over 8. Okay. So my equation now is y is equal to an eighth times 4 to the power of x. So then, we're looking for the value of k. So when x is equal to minus 1, y is equal to k. So we have k is equal to 1 over 8 times 4 to the power of minus 1. So k is equal to 1 over 8 times 1 over 4. So k is equal to 1 over 32. Pretty. That's definitely part of the unseen marks, let's put it that way. 4 marks though, that's harsh. I would have said 5 or 6 for sure. But, you know, examiners be examining. Is that okay? Is there any part of that doesn't make sense? That's a tricky question. I'm not going to lie to you. Especially non-calculator. Especially this bit. I think this is something you haven't really seen before. At least, it doesn't really come up in my school lessons. All good? And you're funny, is that okay? Yeah, that was the answer from the mark scheme. Thank God. At least we know I'm still not waffling. Okay, perfect. Hopefully it all makes sense. That is a bit of a question, man. Okay. Yeah, perfect. So, we have time for another question. Again, unless you guys have a question that you want to ask me. But yeah, this is the predictor paper I had. Also, what would you like me to do next week is also a question that I'd like you to think about. So, this is what I suspect. Again, not the exact numbers. A general physics question. I absolutely can answer a general physics question. Hopefully, anyway. Bear in mind, GCSE physics, it's not the most recent thing I've done, but I'll do my best to help you out with that. So yeah, this is a paper one, so it is a non-calculator paper, and I suspect they're going to do something similar to this for the final question. What's the easier way to do a simultaneous equation? Okay. Okay, give me 2 seconds then. Probability? Yeah. I think we've done probability before. Yeah, we've done it. So I have a couple of lessons on it already, but if you have some other types of questions, that's fine. So I don't get how you take the 2 and put it into 32. After all that effort. Yeah, the exams last year was really tricky, so they might make it slightly easier for you. So keep in mind, Evie, I do have 2 other versions of paper 1, and I think those final questions are a bit harder. A bit. Okay, so anyways, you're funny. I don't get how you take the 2 and put into 32. This bit here. Is that what you mean, you're funny? This part over here? But yeah, Evie, I do have like a couple of other predictor papers. Again, I keep talking about these, but I haven't finished them yet. It's been a pretty hectic. But next week's strike day, so I should hopefully get some finished. But I'm going to try and get it done. You might notice that the mark schemes, I've written the mark schemes myself. But so I've written the mark schemes myself, but I got my friend who has an iPad, and she's she's got very nice handwriting. She rewrote them for me, so I'm just waiting on her to finish the mark schemes, but it should be pretty good. So 32 equals this bit. Okay, cool. And you're unsure. So to move it over across. I get you, yeah. So, are you okay with the fact that this would be the same as writing the square root of b all to the power of 5, where this is just the square root? That's what that 5 over 2 is, right? God, my voice is really tired. If that's okay, then what I want to do is get rid of the square root. So I've squared both sides. Which gives me 32 equals b to the power of 5. 32 squared to the power of b to the power of 5. So all I've done from here to here is I've squared both sides. If you're not sure about that, I can write it out fully in like the technical mathematical way. Because technically this is skipping a step. Technically. But if you square both sides, it would get rid of the square root sign. So I can show you in terms of indices if you prefer. To be fair, Evie, it's not even smart, it's just like A-level maths and stuff. Yeah, you get that? So is it okay after that? So then I'm taking the 5th root of both sides, and that's where I get the next line, and so on. Honestly, this is a tricky question. That's what I mean, is that this is advanced algebra that I would expect in A-level maths. That's why. Yeah, no problem. No worries, no worries. But, like, honestly, don't feel bad if you weren't too sure about that. This is a hard question. Like, just it's just hard. The algebra is very tricky, especially for non-calculator. Okay, so we'll do this quickly, and then Evie, I'll answer your general physics question. That's okay? So, the diagram shows 2 right-angled triangles. Calculate the value of x. Okay, so let's think of how to explain this. Okay, this should be fine. They give me an angle, and it's a right-angled triangle. So the first word that pops into my mind is trigonometry. Right? That's what pops into my head straight away. Now, I have an unknown side and an angle, so yeah, that's good. But the thing is, with trigonometry, I need to work out one of the other 2 sides. Okay? Now, is it possible for me to ever work out the hypotenuse? Well, if I look at this, I don't think so, right? I don't think I can work this out. Okay, so let's look at the other side. Right? So keep in mind again, the question has to be completable. So this side must be the one. Well, if I have a look, I have a side and an angle, so I should be able to use trigonometry to work out this other side. right? Now what is this side? This is the opposite side, this is the adjacent, and this must be the hypotenuse. So, using SOHCAHTOA for this top part, I want O and I have A, so I'm going to use that. So, tan 60 equals the opposite, I'm just going to call it O for now, over 6. Now, what is tan 60? Well, again, that should be one of the values you remember just from... there's just one of the values you need to remember. Tan 60 is root 3 equals... Actually, is it confusing that I've used O as the letter? Because it looks like 0 over 6. Okay. There's an easy way to fix this. I'm just going to call it op. Okay? So that op side is just equal to 6 root 3. Okay. So far, are we okay? Probably should give him more space for this answer, actually. Okay, so I'm actually just going to write it up here now. So, we now have a side, and we want to work out an angle. Funnily enough, this is still O for the opposite, and this is the adjacent, right? And this is the hypotenuse. So again, we're going to be using tan. So again, we have tan 30 equals opposite, which is 6 root 3, over x. Okay? And tan of 30, as you may be aware, is just root 3 over 3. Now, a little algebra trick that you might not be aware of is that if you have things on the opposite sides of the equal sign that are on the same, so if they're both in the numerator and on the opposite side of an equal sign, then you can actually just cancel them out straight away. Because basically all I'm doing is dividing by root 3. Okay? So as another example, if you had 2x over 3 equals 4x squared over 2, because you have an x on the same side of the fraction, so in this case you have them both in the numerator, you can cancel them out immediately. This also works if it's on the bottom of a fraction. So 1 over x squared equals 2 over x. You can cancel out those as well. Is that okay, or would you like me to actually go through it a bit more in detail? You can cancel numbers if they're the same as well. Right, so if I had like 4 over x equals 2 over y, I can cancel out the numbers like that. And vice versa if it's on the other side. If you don't believe me, that's fine. Do it the other way. Or, I mean, ask me to do it the other way. That's completely fine by me. But it is a bit of a trick you can use. But I would suggest proving it for yourself would be the best way to do that. So, kind of like algebraic fractions, yeah. In fact, it is an algebraic fraction. So 1 over 3 equals 6 over x. So I'm going to times both sides by x. We get 1 over 3x equals 6. Times both sides by 3, we get x is equal to 18. Oh, my voice is suffering. Any questions about that at all? None? All good? Yeah, perfect. Okay. So next week, I can try and find some slightly trickier probability questions. We may have done it. There was like a tricky kind of ratios question, but I think we've already done it, to be honest. Pretty sure we've done it. But yeah, what other topics would you like? Or like, would you want some exam paper walkthroughs? Or like, what next? because we're running out of topics. So these are the list of topics we've done. We've done a good chunk of them. Yeah. Okay. If not, I'll think of something, and I'll pick one that might be a bit tricky. Look through my predicted stuff, see what might come up. But if not, then we can definitely call it here for the lesson, and Evie, I'll answer your physics